Hi all, myself Anjusha R, Assistant Professor, Department of Civil Engineering, Vedavyasa Institute of Technology. Today, I would like to discuss a topic on earthquake-resistant building construction. We all know an earthquake is a vibration, sometimes violent to the Earth's surface, that follows a release of energy in the Earth's crust. This energy can be generated by sudden dislocation of segments of the crust, by the volcanic eruption, or even by a man-made explosion. So the dislocation of the crust causes most destructive earthquakes. Now we can go through how earthquake-resistant construction is different from our ordinary construction. We all know while designing a building, a lot of forces or what all are the forces coming over that building is to be computed. Based on that, the design purpose is done. So since the magnitude of a future earthquake and shaking intensity expected at a particular site cannot be estimated without reasonable accuracy, the seismic forces are difficult to quantify for the purpose of design. So further, the actual forces that can be generated in the structure during an earthquake are very large, and designing the structure to respond elastically against these forces make it too expensive. The effect of earthquake on reinforced concrete buildings. So we know a typical RC building or reinforced concrete building is made of horizontal members such as beams and slabs, and vertical members such as columns and walls, which are supported over the foundation which rests on the ground. So this system consisting of RC columns and connecting beams are called an RC frame. In this figure, you can see that the total horizontal earthquake force in a building increases downwards along its height. That is, for ground floor, the horizontal earthquake force is maximum or is more than the other top floors. Now coming to seismic design philosophy, we know the severity of ground shaking at a given location during earthquake can be minor, moderate and strong. Relatively speaking, minor shaking occurs frequently, moderate shaking may be occasionally, and strong shaking rarely. So earthquake design philosophy and earthquake resistant building is a important concept that should be dealt with in construction of a RC building or any high-rise buildings. Some of the remedial measures to minimize the losses due to earthquakes are building planning, that is, the planning of the building that is to be constructed should be proper and based on the earthquake considerations. Foundations, band to provision for band providing, arcs and domes, staircases, etc. Now coming to a topic that mid-level isolation. This mid-level isolation system that is installed while the building are still being used. This new method entails improving and classifying the columns on intermediate floors of an existing building into flexible columns that incorporate rubber bearings, which is known as base isolation system, and rigid columns which have been wrapped in steel plates to add to their toughness. So this is a new method that is considered in earthquake resistant structures, that is mid-level isolation system is provided. Now coming to earthquake resistance using slurry infiltrated matte concrete. In short, it is SIMCON, which is widely used in earthquake resistant building constructions. So we know the devastating earthquake in Turkey that has killed as many 20,000 people and injured another 27,000. Images of survivors trapped beneath the rubble of collapsed buildings appear daily in the news reporters worldwide. So now Carolina State University engineer is developing a new type of concrete to help prevent such scenes from happening again. So SIMCON is a newly invented concrete that is for earthquake resistant structures. Some of the traditional earthquake resistant housing that are considered are the Feroz of Uttarkashi, Daji Diwari buildings of Kashmir, Katki Kuni buildings of Kulu Valley, Quincha earthquake resistant buildings, etc. So as a conclusion, we can say there is a lack of awareness in earthquake disaster mitigations, which avoiding non-engineered structures with unskilled labor, even in unimportant temporary constructions, that can help a great way. So the building should be constructed as per guidelines given for earthquake specifications, like for Indian standards, Euro codes, etc. As per the zones of seismic zones are considered, we have to design the structure as per the guidelines given by the standards. The statewide awareness programs have to be conducted by fully exploiting the advancement in the information technology. Urgent steps are required to be taken to make the caudal provisions regarding earthquake resistant construction undebatable. So these are the main conclusions that I have discussed. So thank you all.